Okay, today we're going to go over simplifying complex fractions. It's section 6.3 in your homework. Your book goes over really two ways to do this, two different kind of paths, I guess you could say, to simplify complex fractions. I'm going to stick to one. This one path kind of, to me, I believe it works best for both. The other path really works best for one type of fraction. So I'm going to stick to that. Let me get this saved. Okay, there we go. Okay, so let me get to the document camera. So first off, what is a complex fraction? Well, a complex fraction is really when you have a fraction inside of a fraction. So let's look at an example here. Let me get this at the right angle. And so a complex fraction has a fraction inside of a fraction. So if we looked at kind of a basic example with just numbers, let's say we had like 1/2 minus 1/4 over 3/8. Okay, here's an example of a complex fraction. We've got multiple fractions inside fractions, right? We have 1, 2, 3 fractions inside of the larger fraction, which means we're going to have a complex fraction, which, look, we're just going to learn how to simplify these today. There's no solving or anything like that. We're just going to get this down into a single fraction or a single number sometimes, depending on how large the fraction is. So I'm going to use this example to go over how I work these, even when we get to like larger binomials, and I believe maybe trinomials. I think they kind of stick to binomials in the book. So the way I work these, the path I take, that is one of the paths that your book goes over, is actually getting rid of the fractions inside of the fractions. So what you're going to actually do is identify for this example, there's 3 fractions inside the big fraction, right? So we've got this first fraction here, the 1/2. We've got the 1/4, and we've got the 3/8. Okay. And to simplify this, what we're going to do is we're going to actually multiply all 3 of those numerators by the common denominator. So if you're not sure how to find a common denominator, it's just the least common multiple between all 3 of these denominators. So if we look at the denominators here, I wonder if I've got another marker. I don't know if this will show up on here. The denominators are 2, 4, and 8, right? So the least common denominator between 2, 4, and 8, which really is just the smallest number that all of these can divide into evenly. Well, it's going to be 8 actually for this one. 8, 2 goes into 8, 4 goes into 8, and 8 also goes into 8, of course. So the way we do this, now I'm going to rewrite this on the side just because I've marked it all up. So 1/2 minus 1/4 over 3/8. So the way we do this actually is multiply every single numerator by the common denominator. So again, for this example, the common denominator is 8. So I'm going to multiply every single numerator by 8. Okay. Now, when you do this, what's going to happen is it's going to cancel with each denominator. And we haven't violated any math laws because really all we're really doing is multiplying 8 in the numerator and denominator. It's like we're multiplying by 1. Okay. But we can multiply as long as you multiply every numerator by 8. And really what you're doing is you're multiplying every number by 8. Okay. 1/2, 1/4, and 3/8. Multiply them all by the same number. You haven't violated any math laws. But let's see what happens when we do this. I'm going to kind of take an extra step here. Look, 8 times 1, that's 8/2. 8 times 1, that's 8/4. Over 8 times 3, that's what, 24? Over 8. And what will happen if we do this correctly, each one of these will divide evenly. So 8 divided by 2 is 4, minus 8 divided by 4 is 2, over 24 divided by 4 is 3. So we wind up with 4 minus 2, that's just 2/3. Check that out. This whole fraction here, big old monstrosity, simplified down into just 2/3. And really that's what we're doing today. We're going to simplify these down, these complex, this is called a complex fraction, okay? This is a complex fraction. This is not a complex fraction because there's no fractions inside of the fraction, okay? Complex fraction has fractions inside fractions. This one does not, okay? So I'm going to do a few more examples with numbers before we actually get to the variables and the binomials and stuff like that, okay? So let's look at this. Let's say I had, actually, I wonder if I can just do another one. So I'm not using this much paper. Let's say I've got one like, let's say a fraction over a fraction. Let's say 3/4 over 2/5. So again, you've got to recognize what the fractions are. And for this one, the smaller fractions are 3/4 and 2/5, right? So then we have to think of a number that 4 and 5 are both divisible by. The easiest way to do this is actually just multiply them together. 4 times 5, that's 20. But sometimes the smallest number won't be that. So you'll have to really kind of think through. But the goal is just to find a number that's divisible into 4 and also divisible into 5. So yeah, it is going to be 20 for this one, right? So let's see here. Hey, look, if you're having trouble identifying least common denominators, you can email me and I can find, there's a ton of videos on YouTube that are really good videos actually on how to find least common denominators. And so if that's hanging you up in this section, you can Google it yourself. You can email me. I don't mind finding some supplemental videos. It doesn't take long for that to click. Okay. But let's go about this. So I'm going to multiply 20. Now remember, I've got to multiply by the numerators. I'm going to multiply 20 to the numerator. So on the top, I wind up with 20 times 3, that's 60 over 4. 20 times 2, that's 40 over 5. Now 60 divided by 4 is 15. If you need to crack a calculator open, that's fine. 40 divided by 5 is 8. So you wind up with 15/8, which does not simplify, right? 15 and 8 are not divisible by anything in common. And also, which is important for this class, now let me see if I can get this a little bit better in focus. Look, do not write this as like 1 7/8. We're going to leave it as an improper fraction, okay? This is called an improper fraction. And it's because if we want to do anything to it later, it's a lot easier to manipulate an improper fraction. A proper fraction, which we're not going to go to, but you've learned in the past, would be to call this like 1 7/8. Which, if you're dealing with real world numbers, this is the best way to go, right? If I tell you that something your recipe calls for 15/8 of whatever sugar, but that doesn't make much sense. But if I say, well, 1 7/8 cup of sugar, it makes more sense, right? So this is called a proper fraction. Use more in the real world, use more in mathematics, okay? So we're going to stick to the mathematics one for now because that's what's going to help us once we go on to college algebra, which is our goal, okay? Okay, so we've got fractions. Okay, let's do another one that's kind of different, that switches it up a little bit. Let's say we've got, let's say we have integers and fractions going on. Let's say we had like 4 minus 1/2 over, let's say 3/5. Okay, now I'm going to do this. I'm going to add an extra step here to show you where your brain kind of needs to go with that 4. Notice we do have fractions inside fractions, 3/5 and 1/2, right? And you might say, well, Mr. Shirley, that 4 is not a fraction. Well, really, it can always be written as a fraction. An integer can always be written as a fraction because it's just 4 over 1, right? 4 divided by 1 is 4. So if you see an integer, you can think of it as 4 over 1. It's 1/2 over 3/5. Now the common denominator here, I've got 3 fractions. The common denominator, we've got 1, 2, and 5. Well, it's going to be 10, right? 5 times 2 times 1 is 10. That's the easy way to do it. But it is just 10. 10 is divisible, or 5 is divisible into 10, and 2 is also divisible into 10. And 1, of course, is divisible into anything. So I'm going to take 10, and I'm going to multiply it into each numerator. So I'll use another color here. Almost ran out of this red. So this winds up being 40 over 1 minus 10 over 2 divided by 30 over 5, right? So now all three of these should simplify, right? 40 over 1 is just 40 minus 5, 10 divided by 2. 30 divided by 5 is what, 6? So we wind up with 35 over 6, right? 40 minus 5. I think I've done this one right. Yeah. And again, nothing divides into the top and bottom of 35 and 6. So that's done. Don't tell me that's, what, 5 and 5, 6 or whatever it is. It's 35, 6 for what we're doing today. Okay, so now let's start adding integers into this. So mixing it up with integers. And it's not going to be that much harder, actually. The common denominator is a little bit different to find. So let's say we had 15 over 2x divided by 5 over 6x. So for this one, we just have a fraction over a fraction. Now you get the big fraction bar here. So I'm going to pay attention to just the top, actually to that denominator and that denominator, right? I'm going to think of it like that. We got a 2x and a 6. Well, I know with 6 and 2, the least common denominator would be 6, right? 6 is divisible by 6, and 6 is also divisible by 2. So I know I'm going to multiply by 6 on top and bottom. I'm just going to write that first. But then also they both share an x. And now like for this one, you're always going to multiply like with the variables. We'll see an example next. I'll pull one up. That if we've got the common variable, it's always going to be the larger exponent, okay? And that way it'll divide everything away. So for this one though, it's just x and x, it's common. So we're going to multiply both these by x as well, okay? We're going to multiply both of them by x. So let's do that. So 15 times 6, I have no idea. Is it 75 maybe? No, that's not right. 80. 15 times 6, 90. Oh, wow. So 90x over 2x divided by, now 5 times 6, I do know that's 30x over 6x. And what happens is, the x's will cancel, and then the numbers will divide evenly. So let's do that. 90 divided by 2, I know is 45. X divided by x goes away, right? We know how to simplify that. We've been doing that for a few sections now, okay? 30 divided by 6 is 5, and the x's go away, okay? So for this one, we are left with numbers. Now, we're not always left with a number, okay? The next example might not have that. But 45 divided by 5 just leaves you with 9. So this monstrosity turned into 9. That's pretty cool. Okay. Pretty cool. Okay. Oh, let's do what I was talking about. Let's talk about, well, what if we have different variables with different exponents, or let's keep it the same variable but with different exponents. Okay. So what if we had? And I'm going to steal this one straight from your homework. Let's look at number. And it might keep going. Sometimes these tend to keep going, to keep simplifying, I should say. This is number 14 in your homework. So this is number 14. We've got 2 over x squared plus 1 over x. Hey, we don't have any numbers in the denominators here. 4 over x squared minus 1 over x. Okay, so again, notice we definitely have complex fractions. We have 4 fractions going on this time. So we have to focus. What's the right word? We have to take into account all 4 of these denominators. We've got an x squared, we've got an x, we got an x squared, and we got an x. Okay. And now what I was saying for variables, for common denominators with variables, you always just go with the highest exponent. And x squared is the highest exponent for all 4 of these, right? You got x squared, x, and x. So x squared for both of these. So we're going to use x squared as our common denominator. We don't have a number, so we don't have to worry about numbers here. So I'm going to multiply every single numerator by x squared. So every single numerator gets an x squared. Thrilling, I know. So let's see how this kind of shakes out. So we wind up with 2x squared over x squared plus x squared over x over 4x squared over x squared minus x squared over x, right? Because each one of these numerators now has an x squared. And then what will happen is they'll cancel, right? Look, or the denominator cancel. This first term, the x squared goes away, so you're just left with 2. This is x squared over x. Well, that's going to leave us with just an x. The first fraction here, in the denominator, goes to 4. And the second fraction goes to minus x. Okay? And now, I know your brain. Look at me. I need your eyeballs. I'm going to show you my eyeballs. Hold on. You can see me here, right? Can you guys see me, Avery and Kinley? Can you see me in like the corner of the screen, or is it just the video?
It's just the video of the paper.
Okay, perfect. Hold on here. Listen, I know with this example right here, your brain wants to cancel the x's, and it wants to cancel maybe this 2 and this 4 and make it 1/2. Okay? And this is where we have to be careful. I know in the past I've talked about how humans have the greatest ability for pattern recognition. This is one of those examples where it gets us in trouble because we have such a beautiful pattern recognition skill. Okay? Remember, or a way to get out of that habit is by putting parentheses around the top and bottom. And we can only simplify if the parentheses match, okay? The reason the x and the 2 and the 4 do not cancel is because they're not being multiplied. They're being added and subtracted, right? The top's added, bottom subtracted. So we can't cancel. And I'll tell you, most common mistake, hands down, in this section, whenever a student grasps, simplifying these things and multiplying and simplifying, multiplying, dividing, and simplifying complex, and then we're going to get to like solving is actually the easiest, but solving, this will be the most common mistake on a test. Okay, so when a student understands it, and you want to say, oh, that's a goofy mistake, yeah, but it's not a goofy mistake if you keep making it. Okay, it's a goofy mistake if it happens once or twice and you realize, oh man, I made a goofy mistake, I fix it. Okay, this is a common mistake that happens a lot, that keeps happening because of the pattern recognition aspect. Okay, so take that into account. We are done here. This answer is over. Okay, look how much better in focus this is than my dang desktop camera. Okay, I need to put in. It was hard to find desktop cameras in the fall because everybody went online, so I guess we get what we got on that one. Let's go back to this. Okay, so let's do a few more here. Let's do a few more of these. So let's see. What if I put it closer? And that does get better, but it kills the paper. Hold on. Maybe I can just do that and keep it into account. The focus button just doesn't work. Hold on, guys, give me 2 seconds. It just doesn't work like I want it to work. Okay, so let's do another example. Let's say we had let's do number 8 in your homework. I know I'm kind of all over the place. Let's do number 8. My hand looks huge now. 5 minus 3 over x over x plus 2 over 3x. Okay, so 5 minus 3 over x, and then x plus 2 over 3x. Okay, so let's look at this. Now, look, right off the bat, I'm going to say these are over 1, right? Remember we did that example earlier. If we've got a number by itself, we can just say that it's over 1. And then I'm going to look at all 4 of these denominators. Now look, these are just a 1, they don't count. We're just looking at x and 3x. Okay, look, we're going to need a 3, right, to get rid of that 3. So I'm going to have to multiply all these numerators by 3 because of that one single 3 there. We're also going to need an x because x is in both of these. Now it's not x squared or x cubed, so we just need an x. So I'm going to need to multiply all 4 of these denominators by 3x. So I'm going to change the color up. No, this marker needs to go away. But I'm going to multiply all 4 of these by 3x. So when I do that, I wind up with 15x over 1 minus 9x over x, right, over 3x squared over 1 plus 6x over 3x. Okay, so if we simplify these, we wind up with, that's just 15x, minus, now look, the x's cancel here, so minus 9, over 3x squared plus, 2? Okay. So now I'm going to put these in parentheses. I should have been doing that all along. I guess we've only had a few that have been binomials. But look, now once we simplify the complex aspect and we get to here, this turns into a section 6.1 problem. Okay? We need to see if the numerator and denominator simplify further. Now I'm going to make a little arrow here. Okay? And remember, to simplify, we factor the numerator and denominator completely. So this numerator, we've got 15x minus 9. We can factor out a 3. And it leaves us with 5x minus 3, right? The denominator, though, doesn't simplify. Nothing factors out. This isn't factorable. It's not a difference of squares or anything like that. So we're left with that. And actually, we're done. So this doesn't wind up simplifying further, but we have to do that last step just in case. We'll see some examples coming up where that just in case thing happens, okay? Where the just in case actually happens. Okay. Questions, comments, concerns? Okay, well, let me go back out here. I don't think it's that much better. I'm going to try to get a little closer. There we go. A little bit. Okay, so let's do, I'm going to keep rock and roll with examples that your book kind of throws out there. Let's see. Do one that, no, well, let's do one that, guys, give me 1 second. Let me think. Okay, let's 22. I think 22 keeps going. That's what I wanted to show an example where, hey, we simplified the complex part, but then we have to keep going with the fraction. So 22 says 2 plus 1 over x over 4x minus 1 over x. Hey, okay. Look, automatically I'm going to write these as, if they're just an integer, I'm going to put them over 1. And it's just to let my brain know what's going on, okay? Just to let my brain know that, hey, this is just a fraction, even though it's written as an integer. Okay, and now look, this one's not bad, right? If we look at the denominators, I'm going to use a different color here. If we look at the denominators, we got x, and the ones that don't really matter because they don't cause anything, cause any disturbance. So I'm going to multiply all 4 numerators by x. Okay, that's the only denominator, right? So it's the least common denominator. So we wind up with 2x plus, well, x over x, right? Over 4x squared plus, oh, that's a minus, right? X over x. So x over x is just 1, right? So we wind up with 2x plus 1 in the numerator over 4x squared minus 1. Okay? And now we have to check, hey, can we keep going? Does one of these factor? Well, the numerator is not going to factor. 2x plus 1, nothing factors out. And it's not like a trinomial that can factor or a second degree. The denominator, though, can factor. And this is from section 5.6. This is a difference of squares. So if I wanted to rewrite this to factor with difference of squares, it'd be 2x plus 1 on top. And then this 4x squared, that's 2x squared, right? Minus 1 can be written as 1 squared. So we wind up with 2x plus 1 over 2x plus 1 times 2x minus 1. You need to go back and see that. That's fine. But it's in section 5.6 called difference of squares. And what's nice is these cancel. Now remember, if everything cancels in the numerator, you've got to write it a 1 up there. So we get 1 over 2x plus 1. Hey, this one did keep going, okay? This one kept going. Okay, let me give you another one, and then we're going to switch to, but what if we have binomials and denominators? What if we have binomials? So I want you to try this one. Oh, hold on, guys. Let me see if I can find a good example. I'm on the hunt for a good one. Yeah, okay, here we go. So let's try this one. Oh, we haven't done one with multiple. Okay. I'm going to do this, or I'll do this one with you. So we got x over, unless you want to just pause it if you're watching it later, x over y squared, 1 over y, over y over x squared plus 1 over x. Now, the reason this is different, this is an example in your book. So x over y squared plus 1 over y, and then y over x squared plus 1 over x. Now, the reason this one's different is we have two different variables. We got a y and an x, right? So if we looked at all 4 of these denominators here, so we've got y squared, y, x squared, x. So we have 2 different variables we have to deal with. We've got an x and we got a y, so they're both going to be in our least common denominator. And we use the highest exponent for both. Well, y squared is the highest exponent, and x squared is the highest exponent. So I'm going to multiply all 4 numerators by x squared, y squared. Okay, so all 4 numerators by x squared, y squared. Now let's see what happens. In the first fraction, I get x squared. X cubed, right? This would be x times x squared. So I wind up with x cubed, y squared over y squared, plus x squared y squared over y, all over, I might have to go to a new page on this one, all over x squared y cubed, right? Because there's a y cubed there, or x squared, plus x squared times y squared over x. That's a lot going on, right? It's a lot going on. We got to be careful that we keep up with the exponents. X times x squared is x cubed. Y times y squared gives you the y cubed, right? And then, the denominators don't change. So let's see what cancels here. The y squareds cancel. The y and one of the y's there cancels, right? X squared and x squared cancel. And x and one of the x's cancel. So this leaves us with, and I'm going to write this a little smaller here, leaves us with an x cubed for this first fraction. The second fraction would leave me with a x squared y, right? Over the bottom fraction would be y cubed. And the last fraction here would be xy squared. It's kind of crazy. Now again, so this, I'll put this in parentheses. we've simplified the complex part. Look, this is not a complex fraction anymore. It's not a fraction within a fraction. So we've simplified the complex part. So now let's factor completely and see if anything simplifies. So if you look in this numerator, we can factor out an x squared from both of these terms in the numerator. So we get x plus y, right? Yep. We can factor out a y squared in the denominator, and we're left with y plus x. Hey, that cancels, right? X plus y and y plus x are the same. That goes away. And it leaves us with x squared over y squared. Man, that was a little harder. Okay, you might say exponentially harder if you like a good pun. Okay. Hold on. Let me. So I found an example. I just want you guys to work. Hold on. Okay, try this one. Try this one by yourself. I'm going to give you a little bit of time to complete it. So we've got 2 over x plus 3 over 4 over x squared minus 9. So I want you to try that one. I want you to simplify this completely. I'm going to give you a minute to work on it. Okay. Just a minute longer. Okay. So let's do this. So I'm going to multiply look, the common denominator is x squared. We've done enough of these now. And if you want to write this as over 1, you can, right? So you wind up with 2x for the first fraction plus 3x squared over 4 minus 9x squared, right? The x squareds cancel. for that bottom fraction. Just 1x cancels here. So in the numerator, we can factor out an x, right? We're left with 2 plus 3x. The bottom, this is that difference of squares. This is 2 squared and 3x squared. So it's actually 2 minus 3x. 2 plus 3x. It's that 5.6 stuff again. This is 5.6, difference of squares. So now we can cancel the 2 plus 3x, and we are left with x over 2 minus 3x. Boom. Okay. Oh, that's fine, Kenley. So then now let's do the binomial stuff. So binomial, which really isn't bad. You just really need to space it out on your paper. If we have a binomial, we treat it just like a, if we have a binomial in the denominator, we treat it just like a common factor. Now let's find a kind of a basic one first. Yeah, like number 6 in your homework. So we've got x over, this one's super easy, x plus 2 divided by 2 over x plus 2. Well, the denominator here is x plus 2, right? And it's actually common. So therefore, we're going to multiply. It's the only thing in the denominator, right? So we're going to multiply both numerators by x plus 2. And it cancels. They cancel completely. This one's just ridiculously easy. It leaves us with x over 2. Okay? But if we have something that doesn't cancel so easily, so let's look at another example where we wind up with a fraction that just doesn't cancel as nice. Okay? Or clean, I should say. So let's say we had, okay, let's look at, kind of take off there, don't they? Let's look at 18. We're going to do some cleaning up before we get to actually simplifying. So we've got 3 over x minus 4 minus 2 over 4 minus x over 2 over x minus 4 minus 2 over x. Now notice we really have 3 different denominators here. We've got an x minus 4 on these 2 denominators. We've got a 4 minus x and an x. But remember, Dr. Martin Gay, the author of this book, for some reason loves this goofy trick where you can move, the x to the front and the 4 behind the subtraction by factoring out a negative. So we did that in the last lecture. If this doesn't look familiar, go back to the last lecture. I went over it more in detail then. But what happens is we can switch this 4 minus x into an x minus 4 by factoring out a negative. So the way that looks is you'd have 3 over x minus 4. This negative is going to become positive once you factor the negative out. Okay? And then it switches that fraction, or that binomial from a 4 minus x to an x minus 4 over 2 over x minus 4 minus 2 over x. So now, well, what's the common denominator here? The common denominator, well, one of the factors is going to be x minus 4. It's in 3 of these denominators. The other factor is going to be x. So the LCD here, I'm going to kind of write it. Write it. Dang it. So the LCD, the least common denominator, for this one's going to be x times x minus 4. Okay? One of the denominators is x. It's got to be in there. And then the other 3 are x minus 4. So it has to be in there. And now this is when it's going to be goofy. We have to kind of space it out. But you're going to multiply each one of these by x times x minus 4. And look, I'm not going to multiply anything through until I've canceled with the denominator. So I'm going to write this extra step, but you don't have to, okay? So the extra step would be writing this completely out without just canceling, okay? But we'd have 3x times x minus 4 over x minus 4. That's the first fraction, right? Plus 2x over x minus 4 divided by x minus 4 over 2x times x minus 4 over x minus 4 minus 2x times x minus 4 over x. Okay, so that's just multiplying x times x minus 4 into all three of these. Notice we've kind of smushed it into each numerator. Now we've got to cancel, though, with the common denominator. Look, this x minus 4 cancels with that x minus 4. Same thing here, and same thing here. Now here, though, that's different. It's only an x, so we only cancel that one x there. So we're left with, in the top left fraction, we're left with 3x. The top right fraction, we're left with 2x. The denominator, we're left with 2x there, minus, now we've got a 2 times x minus 4, right? The x just went away, so it's 2 times x minus 4. So we have to simplify this thing. Well, 3x plus 2x is just 5x for that numerator. I've got to distribute the negative 2 to both terms, so I get 2x minus 2x plus 8. Hey, 2x minus 2x goes away, and we are left with 8. So this winds up being 5x over 8. Holy cow, right? That took a while. Now I'll tell you, you don't have to write this part out. Once you multiply each one of these, like at this point, you could have canceled this and this, and then gone straight to writing it here, okay? You don't have to write this all out if you don't want to, okay? That's a lot of extra steps. You don't have to do that, okay? Questions? I'm going to do one more example, and really we're going to be done today. We're done a little bit early for the class time anyway. It's not going to be an hour and 15 minutes. Okay, so let's do one more. I'm going to do one of the kind of more complex fractions. Okay, so this is number 34. 2 over x plus 2 plus 6 over x plus 7 all over 4x plus 13, put that in parentheses, over x squared plus 9x plus 14. Okay? Man, this is number 34 in your book. It's on page 459. And before we get started here, look, as it's written, there's 3 different denominators. We'd have to multiply each of these 3 numerators by x plus 2, x plus 7, and x squared plus 9x plus 14. So look, before you get going, let's see if this factors. Hint, it probably will, okay? So let's see if this factors. So I'm going to write this down. This actually would factor. X squared plus 9x plus 14. That's 7 and 2. 7 times 2 multiplies to give me 14, adds to give me 9. So I can write this in with that numerator factor. Now I'm going to leave some gaps here, and you'll see why here in a minute. Look, this denominator will factor into x plus 7, x plus 2, okay? And look, now we don't have to write as many denominators. We really only have 2 factors. We've got the x plus 2, which is in this fraction and this fraction. And we've got the x plus 7, which is in that fraction and the bottom fraction. So those are the only 2 denominators, or the only 2 factors. So the LCD here is just going to be x plus 2 times x plus 7. So I'm going to multiply that to all 3 numerators. X plus 2, x plus 7, x plus 2, x plus 7, x plus 2, x plus 7. Okay? And now instead of rewriting it, I'm going to cancel at this point. Okay? Now that we multiply these through, I'm going to cancel. Let's bring in another color here. See if I can fish another color out of my. Let's see. Okay. So x plus 2 cancels with that x plus 2, right? X plus 7 cancels with that x plus 7. Now look, both of these are going to cancel, right? X plus 7, x plus 7, x plus 2, x plus 2. We've got a lot that goes away. But let's see what's left over here, okay? Let's see what's left over. This with markers. So in this first fraction, we've got a 2 times x plus 7. That's left over, right? The second fraction, we've got a 6 and an x plus 2 left over. In the denominator, we've got a 4x plus 13. Okay? Now, notice we're not complex anymore. We don't have fractions inside fractions. Now we need to get rid of parentheses, combine like terms, do all that math stuff, the algebra stuff, right? But we don't have a complex fraction anymore. So I'm going to distribute the 2 to both terms and the 6 to both terms. So we wind up with 2x plus 14 plus 6x plus 12 over 4x plus 13, right? So we wind up with 8x, because the x's add together and the numbers add together. So is that 27? Nope, 26. Plus 26 over 4x plus 13, right? And now we've got to check to see, the 6.1 step. Does anything factor completely? Yeah, 8x and 26 I know are even. So at least a 2 will come out. I don't think a 4 will come out because 26 isn't divisible by 4. So I can take a 2 out, and I'm left with 4x plus 13 over 4x plus 13. What? This goes away. We're left with 2. Awesome. Okay? Awesome. So for homework, this is section 6.3, page 459. I want you to do 1 through, there's one I want you to skip. Hold on, I gotta find it here. I think it's 15. Yeah, so 1 through 33 odd minus 15, okay? Don't do 15. It's a goofy fraction, or a goofy factoring that we didn't go over. So 1 through 33 odd, it's not that many, right? It's about 15 questions. But some of them take this long, some of them take, are much quicker. The stuff at the beginning really is a lot quicker. Okay, I'm going to end this. I hope you guys, or if you guys have any questions, if you're watching this later, please feel free to email me and ask questions. Again, if you're not comfortable finding least common denominators, if you get on YouTube and just look, finding least common denominators with variables, and then just with numbers. Both of those, there's a lot of great videos on that, but I don't mind finding one for you either because there's just a lot out there. So if you need any help, please let me know. Guys, we're halfway through the semester. This is a halfway point. This is 3.5 weeks. Okay, so I need us to start now to get prepared for the next part of this class, or not the next part of this class, but the next part of the semester. So we need to start thinking about college algebra. And I need to give you a little information about it. So just be prepared for that over the next week or so, getting us ready. Also, remember the final, which is not that far away. Hold on, let me get into your Blackboard real fast just to see. This is, now remember, this is for the spring 2021 semester, the first 7-week class. Okay. So our final schedule. Yeah, it's going to be, week 7. Hold on, we're in week 4, 5, 6, 7. Yeah. So it's going to be Friday, the February 26th. That seems wrong, but 4, 5, 6, 7. Yeah. So Friday, February 26th. Now, what's different about the final, where, these regular tests I've been giving you, I'm giving you a few days to complete the final. It's not like that. You have to get it done on that Friday. We talked about that in the introduction of the class, but I just wanted to bring that back up. Okay. So you have to get that done on Friday, the 26th, and we'll have more information of that coming as we keep moving along this semester. So again, if you have any questions, any concerns, issues, please email me. Have a good day. Get this homework done, and let's get through this test. I'll tell you, once we're done with this test, it's a little more downhill moving forward. Okay, I'll see you guys. See you, Kinley. Have a great day.